As with hypothesis testing, in Chapter 11 we take confidence intervals and we kick it up a notch, just like we did with hypothesis testing. So we take what we did with one sample, confidence intervals, hypothesis testing, and we expand it to two samples, or two independent samples in this case. So here's the formula. Lovely. No need to memorize it. It's on your front page of your inferential statistics cheat sheet right here. Two sample proportion. There it is, plus or minus. So no need to memorize it, just need to know when to use it. Notice it has some conditions, namely got to be independent, kind of obvious, and you have to have n times p1, n1 times p1 times 1 minus p1 to be greater than 10, and so on. And remember, that second point right there is to ensure normality, or normal-ish, right? Because it's not really normal, but it's close enough to count. We learned that in 8.2. And then we also learned that we want the sample sizes to be pretty small, less than 5%. That ensures that independence necessary. Okay, so there's the formula. Ta-da, beautiful. Okay, so we're going to construct a 95% confidence interval for P1 minus P2 from that TV aggression study that we were working on, a couple pages ago. Right back here with these kids that watched a little TV and watched a lot of TV. First thing to notice is that, oops, not there. First thing to notice is that, remember that P1 we already found. It's 5 over 88, which is 0.057. P2 was 154.619, which is 0.249. So we already learned all that stuff, so that's fine. And then that's the formula. It's ugly and brutal, but it is what it is. Now, since we're doing a 95%, remember you can find your 1.96, because all I did for the rest of it is just substitute everything in, right? Oh, I suppose it wouldn't hurt to remind ourselves that this is x1 over n1. Remember, that's how you find p hat. We learned that formula back in chapter 8. And then this other one is equal to x2 over n2. So down here in the formula, that's why I put 619 over here, because that's n2, and so on. Okay. Now, I know I've got the answer there, but of course we're going to back it up with StatCrunch in a second. So, but the one thing I wanted to show you was how to get the 1.96, because, I mean, you could type all this into a calculator. I mean, you really could. It's not, it's just kind of ugly, but we'll make StatCrunch to make our lives a whole lot easier. But you should still know how to find that 1.96. And the reason is because if it's a 95% confidence level, that means 0.025 is in the tail, each tail, and then you go down here, it's 1.96. Or if you go back to the normal curve table, this one, you can see, hey, we're doing a 95% confidence, so our critical value is 1.96. So that's another way you can see it. Okie dokie. So we got that, and then you can see the answers right there, but we will back ourselves up with StatCrunch because that's how cool we are. So let me go, oh, you won't want to see it there, StatCrunch. All right, so I go to my StatCrunch. Oh, I was already in there. What was I doing? Open StatCrunch. All right. Stat proportions to sample, because this is chapter 11's two sample. Chapter 9, we did one sample, right? So now we're in two sample. We don't really have data. Data would be like, yes, more aggressive, no, not more aggressive, yes, more aggressive, yes, more aggressive, yes, yes, no, 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 yes, no, right? Stuff like that. We don't have that. So we're going to do with summary. We'll type 588. Oh, rats. 150 something. What was it? 154. Haha. Little Java thing. Here it is. All right, 154 over 619. Click next. And then we're not doing a hypothesis test. We're doing this confidence interval bit down here. So click on confidence interval. Say what percentage you want, which we want 0.95. Calculate. And there it is. Copy. And paste. All right, let's put it over here. This is 11.1. Example 3, I think. No, example 4. Yep, example 4. All right, so I got that in there labeled. I will just paste. I'm going to make it click so everything's good. And there we go. I'm going to save my technology file that way. In case my computer dies, I will still have it somewhere. All right, closing that. Closing that. Let's get back to my lovely thing. So there you go. That's those numbers. Negative 0.2511. It's right here. Negative 0.2511 and 0.1328. And I'm just kind of rounding a bit. I'll be a little bit fast and loose with my rounding here, but there you go. Well, what was the point estimate for the difference? Now, this was accidentally missing from the notes originally when I typed them, so I put them back in. So if you don't have them, just write this question in. So the point estimate is the middle, and I just drew a picture down here so you can see. Over here on the left-hand edge is 25%, negative 25%, right? And over here is negative 13%. The point estimate is smack dab in the middle. So how do you find it? Well, you don't find it this way. You find it by taking the two of them, adding them up, and dividing by 2. Oops. There you go. So our numbers were this is totally wrong, negative 0.2511 plus negative 0, oh, that's probably terrible. Well, here, plus negative 0.1328. You add those two up and you divide by 2. Or if you did it in StatCrunch accidentally, you can see it right here. Right there. See that sample difference? That's the one. Negative 0.192. If you are given the computer output, it makes it pretty easy. If you're not given that much output, you can still calculate it really simply with a simple calculator. All right, so you add them up, divide by 2. Ta-da! You've got it. So it's the center of this interval. So this interval ends over here at negative 0.25, ends over here at negative 0.13. So the middle is the negative 0.19. I guess it's really 19.2% to be fair, because that's the way I've got it drawn here. I've got it drawn with the percentages rather than the decimals. All right, so that point estimate, center of the interval, equal on both sides, because this was made off the normal curve, which is symmetric. All right, now what's the margin of error? The margin of error is the distance between, you can do it a couple ways, and I've labeled it 2 ways. So you can see it's this distance over here on the right, which I've labeled in purple, which is 5.9%, right? Or it's this distance over here. So you can find it a couple ways. You can find it, and I found it up here by doing the high number, negative 0.1328, minus that middle number, which was 19.2%, right? Negative 0.1920. Or you could do it with, let's see, take the middle one, which would be negative 0.1920, and then subtract negative 0.2511, which was the left-hand edge over here. And you're going to get the same number both times, right? So you can find it that way. You can also find it by taking the highest minus the lowest. So you could take like 0.13, take away 0.25, and then divide it by 2, because that margin of error is half the width of that interval. So the interval is the orange part from all the way to the left to all the way to the right. And the margin of error is half of that. It's just like it was in chapter 9. It's either this half on the right or this half on the left. So find it one way or the other. You got to get it. All right, now what does that confidence interval mean? It means that we are 95% certain that the difference in the aggression levels between those who watch a little TV and those who watch, I suppose it would be teens who watch a little TV and those who watch a lot of TV is somewhere between 25.11% and 13.28%. In other words, let me put it this way. In other words, we are 95% confident that teens who watch a lot of TV are 13.28 to 25.11% more aggressive, or more likely to exhibit aggressive behavior. And again, this doesn't necessarily mean that the TV is causing the aggression. It just means that we're seeing a relationship. Oh, one other thing before I flip away from this is that you might have noticed I kind of ignored the negatives. And that's because the negatives are just a side factor of what I chose to be group 1 and group 2. If I had chose the a lot of TV group to be group 1 instead of the little TV, then they would have been positive numbers. The negative doesn't really have any bearing for how we're going to interpret it. Right? We're pretty sure that there's a difference that's between 25% and 13%, or 13% and 25%, and that's what you got to say. The negative's kind of irrelevant because it's totally based on which group you happen to pick to be group 1. Right? All right, now does this, I gave it away right there, but does this imply there's a significant difference? Now let's think about this. We just found that kids that watch a lot of TV are between 13% and 25% more likely to exhibit aggressive behavior. That's pretty significant, right? If they weren't different from each other, if the lot of TV and the little TV groups were basically the same, then wouldn't their difference be, oh, I don't know, 0? Right? Right? That's what we tested back here, remember? Hold on, let me flip back. See? The difference would be 0 right there. See it? Right there. So if they're no different from each other, which is what we assumed back here when we had this hypothesis test, we were like, hey, we think they're the same. If we think the proportions are equal, then we think that their difference should be 0. When you're making the confidence interval for that difference, then you should be close to 0. And you're nowhere close to 0. You're between 13% and 25% more likely to exhibit behavior. 0 ain't anywhere close to that, right? Nowhere close. So that means that there is a significant relationship going on. So if the two groups were not significantly different, then 0 would not be, then 0 would be contained in that interval. In other words, since 0 is not in this interval, this means the two groups proportions are very different from each other. Let me see if I can say this again. The lot of TV or a lot of TV group exhibits aggression between 13% and 25% more than the little TV group. Now, we're not sure of that, I know, but I'm just trying to get you to understand what we're saying here. So, our interval here on this, our interval is telling us that a lot of TV group, hey, come here. The a lot of TV group exhibits aggression way more than, i.e., way more than the little TV group. Okay? That's what we're seeing. If they weren't very different from each other, then they'd be close to each other, right? And if they're close to each other, then their differences would be the same. Aggression way more than the little TV group. 13% to 25% more. There we go. That makes sense. Okay. 0 is nowhere in there. If they weren't different from each other, then they would have 0 in the interval. There we go. So if they weren't different from each other, then 0 would be in the interval. Like, for example, what if it had gone from negative 13% to positive 25%? Well, 0 is in that interval, so you can go, they're not really different from each other because 0 is in the interval. But if 0 is not in the interval, then that's a significant difference. Alrighty, we're all done with that one. I think we'll have to come back here to pick up on the reading computer output because we don't have time to finish it in this example or this video. I'll see you back here for that one. And then we'll move on from there to dependent samples.